Hello everyone. In this video, I'm going to show you how to build a palindrome program using a Turing machine simulator using the popular rendering library called Pixi.js, which is a JavaScript rendering library. So here's what the program looks like. And it's basically a Turing machine that uses a palindrome program. So to explain this, practically I'm going to run this program and then I'll explain how it works. So I'm going to select the game speed to be fast because I want to speed things up, and then we'll click on start. So now we start the game, and this machine is now programmed to run a palindrome checking program. So what happens is once that machine goes through its state rules and it gets to a state where it shows a smiley face or the halt accept state, then it knows that this is a palindrome. If it does not get to this state, if it returns a halt reject state, then you know that this string here is not a palindrome. So this is basically a palindrome program that uses the Turing machine simulator. So let me run this again. So here's the strip of values. The Turing machine goes from one value to the other, looking to see if the current input is a palindrome. So in this case, it is. So I've made it so that this is hard-coded. It cannot be modified, but in future versions, I may include a version that can be dynamically inputted for the state of the tape. So right now, I'm going to cover how to build this program using Pixi.js, JavaScript, HTML, and some CSS. So before getting into the development, I'm going to give a brief overview of what an actual Turing machine is. So here's what a Turing machine looks like. It is an idea. It is a theoretical machine originally conceived by the mathematician Alan Turing. The Turing machine is supposed to simulate an infinite amount of computer algorithms regardless of the level of complexity, meaning that it can theoretically compute or simulate any number of computer algorithms, which goes to show how versatile and how powerful it is. So keep in mind that this physical representation of this Turing machine, which is supposed to be hypothetical, is not in accordance with the theoretical concept, because it's not possible to have a tape of infinite length. As you see, this tape is not of infinite length, it's a finite length, and indeed it's not possible to have infinite length tape. So that's why the Turing machine is always going to be a theoretical concept, at least the pure form of it. So if we do some research on what a Turing machine is, so a Turing machine can read and write from and to an infinite tape. It manipulates symbols on this theoretically infinite tape based on a predefined set of rules known as instructions. The machine has a head, which is positioned over a single square on the aforementioned infinite tape, and it performs one of the following three instructions. So it either reads the current symbol under the head, it either edits the current symbol by writing a new symbol or erasing it, or it can move the tape left or right by one square so that the machine can read and edit the symbol on a neighboring square. So it can either move the tape to move the head to a different position in the tape, or it can read the tape, or it can edit the tape, and it has the possibility of editing it to either 0, 1, or a blank. In my program, I represented blanks as these dashes. So I wanted that tile to show that it's actually a space, so I chose to make it a dash. So here's the head component that points to the current position of the tape. And so it's not a very complex system, but it is ingenious in that it uses a set of state rules to govern how this tape is going to be operated. So you can have some state rules such as this. If you start with a state of 0 and you will read a symbol that is a blank, then write blank and then move it to the left. Move the head to the left. If the state is a 1 and you read 0, then write 1 on the actual head that it's currently pointing to, and then move the tape to the left. And then the next state is going to be state 1. Once that goes to the next head position, it goes to state 1 again, because now it's the next state is 1, state 1. So what's the head pointing to now? Let's say it's 0, or let's say it's 1. Then it reads the symbol as 1. Write the instruction to the current head position to be 1 or 0, and then move the tape to the left. Now the state is also 1. So that's how this works. So it's a recursive algorithm that goes through these things until it reaches the stop state. Once it reaches the stop state, the program is ordered to end. And in my program, there are two end states. So there's halt accept and halt reject. Halt accept means that the given string, what you see here, is a palindrome. Halt reject means that it's not a palindrome. So that's the basis of what we're going to build. So that's it for this video. In the next video, we're going to cover the development of this Turing machine. I encourage you to visit this GitHub URL. I'll put a link to it in the description below, where you can download this entire program and see how it works. So I'll give a walkthrough of the most important parts of the code, so that you have a good idea of how this program works. So that's it for this video. I'll see you in the next video where I go over development. Thanks for watching.